In America's top models, well, the linear models, this curve fitting with linear models. So there's this thing called regression. There's anytime you're comparing two different types of measurements, so you're looking at the statistical relationship between them, it's called a regression. So that's what we're going to be looking at. We're going to be talking about these correlation coefficients, or an R value. So a scatter plot is a way to throw data up and then look to see if there's some sort of correlation, where it might go from, in this case, a positive correlation, so that if the line has a positive slope, as you're going through here, there's a positive slope, so it has a positive correlation. A negative slope would be if the things, as time goes on or as something happens in this direction, if things tend to decrease, that's a negative slope, so it has a negative correlation with the data. If things are just scattered all over the place, as you see in this third example, we say that there's relatively no correlation. So we're going to look at some examples of real stuff that fits into all three of these models, but I'm sure you can probably think of a few on your own. The positive correlation, so as something increases, something else goes up. Negative is the opposite, and then things that aren't related, well, it would have no correlation. So again, this is between two variables. It's some sort of linear relationship. If there's a strong linear relationship, you might have done this in science where you do a line of best fit. So you have some sort of experiment, and you have your data, and your teacher may have said, draw a line of best fit, and the old school way with paper, you would have had the points, and then you would draw a line and say, well, that's pretty good, and it helps you to predict, some other points if you were to increase, some sort of solution to see what it came up to be. That's the most common way you might have seen that. We have technology, and with our calculators, we can do a much better job with the line of best fit instead of sort of picking something in the middle of points. When you do that line of best fit, or when you calculate it, you get this thing called an R value. Now, an R is within a range, as you can see here, between -1 and 1. That's the range of that data. If it's 1, that means all of the points are on the straight line. So if we go back to the last example, I had things that were pretty close, but they weren't exactly on the line. The closer they are to being in a line, the closer your R value is to -1 or 1. If the R value is 0, which is right in the middle of this range from -1 to 1, then that means there's no correlation with the data. So a strong correlation, like in this first one, that's really close to that line. So this has an R value of approximately -0.95. If they were all on the line, it would be a -1. In this particular case, they're a little more scattered, so that R value gets a little bit closer towards the middle. Scattered all over the place, we can't draw a good line in any real direction. That R value of 0, that's no correlation. And again, here's one that's, kind of together, but they're quite a ways away from what might be a line of best fit. That gives you an R value of 0.6. And again, this is very much like this first example, except now we have a positive slope, so that puts the R closer to 1. So that's pretty good as far as the correlation between those two variables. So just a quick example here. We have some information about bicycle tires with a mass and a price. And we're going to see if these correlate at all and see if we could come up with some sort of prediction. So making a scatter plot, you're just putting things on the X and Y axis. So we have mass along the X, that's our independent, and then we have price along the Y. See how quickly I did that? You have to get to be that quick putting that data up there. Right? So the next thing, and you can see that the points that are on here aren't great. They're kind of off of that line of best fit. So the R value is probably not going to be awesome. It's certainly not going to be up by around 0.9 or anything like that. So if we have to find the correlation coefficient in the equation of the line, the old school way, the way that you might have done this in science, would be to pick 2 points that are on the line and then come up with the equation. You have your TI calculator. We're going to talk about how to punch this into the calculator and get everything to work out beautifully. It involves using L1 and L2 and doing a linear regression on your calculator. If you're familiar with that, awesome, and if not, we'll go through it in class. This is going to have an R value around 0.6 or so, one of those examples where things are kind of scattered around. And then, you know, if we're predicting the weight of a $40 tire, we can look over here and come across and say that's going to be about 650 grams, because at 40, it's about 650 grams. But how accurate do you think your prediction is? Well, we said the R value wasn't very good. That means our prediction's not very good. So that's how you use it. And that's it for America's top models, linear models with curved fitting. So thank you all, and we'll see you next time.
Here.